Hello and welcome to Weapons of Math Instruction, and Happy Pi Day. In celebration of this day, I'll be releasing a video about pi every day, just like I did last year. This year's introduction video starts out the same as last year's, but then we go in a different direction. I'm going to do a geometrical demonstration that the number pi is between 3 and 4. So I put that inequality here on the thumbnail so that it will look different from last year's. Last year, my videos were quite heavy on trigonometry and calculus, and there's going to be some of that in the later videos in this series, but I wanted to put more geometry into these videos. So you'll be seeing lots of pictures, and pictures are worth 1,000 words, right? So this video will be in two segments, starting with the fundamental question, just what is pi? So that's the question, here's an answer. Pi is the number of diameters of a circle that will wrap around the circumference of the circle exactly once. And now I'm going to introduce some symbols. So if we call the circumference of a circle c and the diameter d, then we have the ratio c over d equals pi, and you could think of this as a definition of pi. So the circumference c is the distance around the circle, and the diameter d is the distance across the circle. Or more precisely, d is the length of any line segment that begins and ends on the circle and passes through the center. So to illustrate my first bullet point, we're going to take the circle apart and reassemble it. So here is a section of our circle whose length is exactly equal to the diameter. And down here, I've straightened out that circular section. Here's another section of the circle of length d, and here I've straightened it out and laid it next to the previous one. And another. And so far, we've wrapped 3 diameters around the circle. But as you can see from this gap, we're not quite home yet. There's not enough room to wrap a 4th full diameter, but rather a little section that's d times approximately 0.14159. And so I've laid that segment here next to the other 3. And the length of this line segment is the same as the circumference of the circle. All I've done is unwrapped it and flattened it out. And so the length of this line segment is d plus d plus d plus d times 0.14159 ... And if I add those together, I get the diameter times 3.14159 ... And this number here is pi. The ... indicates that the decimal expansion of pi never terminates or repeats. And that's because the number pi is irrational, which I'll explain in a video later this week. So if we take this ratio here that defines pi and rearrange it, we get that the circumference equals pi times d. Now, the radius r of the circle is exactly half the diameter, so I've labeled 2 radii here. And a more familiar form of the circumference formula is c equals 2 pi r. As of today, 62.8 trillion digits of pi have been found using supercomputers. Even on a cheap handheld calculator, you can get several digits of pi. But pi wasn't always known this accurately. In this segment, I'll give a geometric illustration that pi is between 3 and 4. Actually, I already gave one in the last segment as I wrapped diameters around a circle. You could clearly see that pi is somewhere between 3 and 4. In this segment, I'll give another illustration. So, consider a circle of radius 1. So the circumference of this circle is 2 pi, because remember, c equals 2 pi r, but if r is 1, then c is 2 pi. And what we're going to do is circumscribe a square around this circle. What does that mean? It means I'm going to draw a square around the circle that just barely kisses the circle at these 4 points and has the same center. So here I've drawn in another radius, right? So the diameter of this circle is 2, and you can see that the diameter of this circle is the same as the length of the side of the square. So this side has length 2, and because it's a square, they all have length 2. So the perimeter of the square, which I'll call PS, that's 2 plus 2 plus 2 plus 2 is 8. So clearly, the circumference of the circle is less than PS, which means that 2 pi is less than 8. So let's get rid of that square, and the next thing we're going to do is we're going to inscribe a regular hexagon inside the circle. What does that mean? It means that the hexagon will have the same center as the circle, and the vertices of the hexagon will just touch the circle. Now, the interior angles of a hexagon add up to 720 degrees. So each one of them is 120 degrees. And you'll notice that I took away this radius. That's because I'm going to draw in 2 more here and here. So this is a radius and this is a radius, so they both have length 1. And these radii cut that 120 degree angle exactly in half. So each of these angles is 60 degrees. And we know that there are 180 degrees total in a triangle. So that means that this guy has got to be 60 also. And that means that the length of this side is the same as the length of the other two. In other words, this is an equilateral triangle. So the length of this side of the hexagon is 1. And this is a regular hexagon, so the lengths of all the sides are 1. So the perimeter of the hexagon, which I'll call pH, that's 6. And so clearly, pH is less than c, because the distance around this circle is greater than the distance around the hexagon. So that gives us a 3-member inequality. 6 is less than 2 pi, which is in turn less than 8. Now, if we divide all 3 of these dudes by 2, then we get that 3 is less than pi, which is less than 4, which is what we set out to show. And this is more than just a crude estimate of pi. This tells us something important. It tells us that pi is not an integer. And if I want to write that out in technical symbols, pi is not an element of the set z of integers. So what's an integer? It's the counting numbers 1, 2, 3, etc. And their negatives, -1, -2, -3, etc. And also 0. Like I said in the introduction, a picture's worth 1,000 words. So here I've drawn a number line with these 5 integers labeled, 0 through 4. And here is where pi sits. And pi sits between 3 and 4. It's not an integer. Why? Because there is no integer between 3 and 4. So thanks for tuning in, and come back tomorrow and I'll feed you another bite of pie. Bye-bye. Hey everybody, if you enjoyed this video and want to see more like it, then please do follow me on my socials. You know you want to.